Newton's laws with impulse and momentum. Recall that impulse, J, is equal to the average force times the interval of time. So the bowler provides an impulse to get the bowling ball going here. And momentum is P, which is equal to mv. The momentum is equal to the mass times the velocity. So once the bowler releases the ball will have momentum. We're going to use Newton's second law again, but this time we're going to use Newton's second law to show the relationship between impulse and momentum. So to start off with Newton's second law, F equals ma, and we're also going to recall that acceleration is the rate of change of velocity, delta v over delta t. So if I plug delta v over delta t in for the acceleration, then what I get over here is that the force is equal to the mass times delta v over delta t. Now doing a little bit of algebra and dividing both sides by delta t here to get rid of the delta t on this side, and I would have delta t on this side now, we would get this equation. Force times the interval of time is equal to the mass times a change in velocity. And lo and behold, what you see here is the average force times the interval of time. Hey, that's the impulse. And that is equal to or causes a change in mass times velocity. Guess what? That's momentum. So Newton's second law, believe it or not, can turn into the relationship between impulse and momentum. And this is a big idea, that impulse is what causes a change in momentum. So again, impulse, which is our symbol J, causes a change in momentum, mass times velocity. And so here's another way to look at that equation. J is equal to delta P. And visually what we can see is the impulse provided by the bowler on the throw of the bowling ball causes a change in momentum. It gives the bowling ball momentum, where the bowling ball didn't have momentum before. Now the bowling ball does have momentum. And so if I took the average force applied over this interval of time and multiplied it together, that should be equal to the mass of this bowling ball times its velocity. Impulse causes a change in momentum. An impulse causes a change in momentum. An impulse causes a change in momentum. Momentum is changed with an impulse. Newton's second law told us that impulse causes a change in momentum. Newton's third law, when we studied it before, we just talked about for every force there's an equal and opposite force, kind of like when we have tug of war here, that this side pulling against that side is equal and opposite to one another. And we kind of had it in a static sense where it was stationary. Well, now we can look at Newton's third law a little differently. We can look at it with impulse. For example, for every action, there's an equal and opposite reaction. Newton's third law can also apply to any kind of interaction. For example, this car crash, or all those other examples we've just been witnessing. So whenever two things interact, one thing is experiencing the exact same impulse as the other, but in the opposite direction. So this green car experiences an impulse from the blue car, and the blue car experiences impulse and a force from the green car. So Newton's third law also applies to impulses, not just forces. And therefore, since impulse causes a change in momentum here, impulse also applies to changing momenta. and therefore the change in the momentum of one object, in this case the bat, hitting the ball, the bat, when it came down to hit the ball, when it hits the ball, the bat actually changes its momentum, it slows down, and the ball speeds up going the opposite way. So the ball's momentum coming in and then going out has been changed, and the bat's momentum has been changed because the swing, when it hits the ball, the bat slows down and its momentum is changed. So Newton's third law also has something to do with momentum and a change in momentum that we get from this idea of impulses causing a change in momentum. So there are three ways now that we can look at Newton's third law of motion. For every action, there's an equal and opposite reaction. So forces have actions and reactions, impulses do, and the change in momentum of one object with the other when they are interacting. And Scratch's parting thought: and good luck on your quest for continuous improvement.